So where were we in the last class? Good evening everyone. Wait a minute when we will start. Okay, so this was about conductivity and molar conductivity, and I already told you that molar conductivity or equivalent conductivity depends more on molarity and normality respectively than conductivity. Okay, since we saw that conductivity decreases, so according, if conductivity is decreasing, that means molar conductivity should also decrease, that will decrease. Air conductivity decreases, that means equivalent conductivity will also decrease. But at the same time, due to dilution, volume increases. If volume will increase, molarity will decrease, and if molarity will decrease, molar conductivity will increase. So here will be both the points are contradicting each other. But after experiment, we saw that either molar conductivity or equivalent conductivity depends more on molarity or normality than conductivity. That's why molar conductivity and equivalent conductivity increases with increase in dilution. Is that clear? Sneha, Hamza. So everyone done with this? You have this written it in the last class, I think. Wait a minute, where were we? Did we plot any graph and then? Okay, no. Okay, variation of molar conductivity and equivalent conductivity. So basically, we have a graph here. Wait a minute, just a minute. The graph is very easy. So the variation, the graph of variation. So it is like, you can see this. This is basically molar conductivity. Draw the graph with me. This is basically molar conductivity. That means Siemens centimeter square per mole. And C raised to the power 1. That means C is for concentration. Concentration, or in some books it will be written as under root C in NCRT. And the unit of C is basically mole per liter raised to the power 1/2. And the variation we are seeing for weak electrolyte and strong electrolyte. So I already told you that the variation in weak electrolyte is more as compared to variation in a strong electrolyte. So when we plot graph, the variation of weak electrolyte, that is, I just took an example or experiment of CS3 COOH, which is weak electrolyte. So the variation is very large as compared to a strong electrolyte. This is for KCl, which is a strong electrolyte. So basically, this is the graph for variation of weak and a strong electrolyte. Please write this. Please let me know when you are done with this. Very good. Now see, there is an equation. Hamza, are you done with this?
Yes.
Okay. So from this, there is an equation for debye Huckel on Sager equation, and this equation is only for a strong electrolyte. Basically, from this graph, this equation comes, and this equation is for only a straight line. Y is equal to mx plus c. As you can see, a straight line is for this a strong electrolyte. KCl is a strong electrolyte, and CH3COOH is weak electrolyte. And the graph of CH3COOH, which is weak electrolyte, is curved. So it is not valid for a weak electrolyte, but only valid for a strong electrolyte. So Debye-Huckel on Sager equation. If you are going to see what is the equation, so the equation is basically lambda m. That means molar conductivity at concentration m, and lambda m naught. That means molar concentration at infinite dilution, minus b root c, minus b root c. Now I'm going to write each and everything, each and every part of this. What is this? So basically, where lambda m equals to molar conductance, molar conductance at concentration c, lambda naught m is equal to molar conductance, molar conductance at infinite dilution, at infinite dilution. And then b is basically constant. B is constant. In NCRT you can see there will be other constant, like it will be written c, a small c at the place of c. B constant, and its value is same for a particular, same for a particular type of, a particular type of electrolyte, a particular type of electrolyte. So basically, this is Debye-Huckel-Onsager equation, which is valid for a strong electrolyte. Please write. Only for a strong electrolyte, you can also write here. Only for a strong electrolyte. Now, today we are going to learn about kohlraush law, which are very important, which is very important. Everyone done with this? Let me know. Very good, Sneha. Hamza. Hamza, are you done with this? Please do reply. Okay, Hamza, a strong electrolyte and weak electrolyte. Have you studied ionic equilibrium in class 11? So always remember that salt of D block element like AgCl, PbCl2, these are all weak electrolytes. Organic acids are weak acids, weak electrolyte. So basically, in inorganic, or you can call the ionic equilibrium, in that chapter, we easily come to know about which one is a strong and which one is weak electrolyte. So basically, in terms of acid, I can say that HCl, H2SO4, HNO3, HClO4, HClO4, HI, HBr. These are all strong acids. And if they are a strong acid, that means they are a strong electrolyte. If I want to tell about base, then I can call NaOH, KOH, CSOH, BaOH whole twice. These are all called a strong base. That means a strong electrolyte, like NaCl and then KCl and then MgCl2. These are all a strong, basically a strong electrolyte, salt there. If we talk about the salt of D block element AgCl, PbCl2, and CuCl2, these are all basically weak electrolyte. Or when we talk about organic acids or bases, wait a minute. Okay, organic acids and organic bases. Organic acid, you know that carboxylic acid, CH3COOH or HCOOH, alcohol, and bases like NH2CH3, amines, and all. These are all weak bases. That means weak electrolyte. Got it, Hamza? Hamza, yes or no? Okay. So that's why teachers and parents or your elder brothers, sisters says that make your basic strong. And this is a good time to make your basic strong, so that in higher classes it will be very easy to understand the new concept. Okay, so everyone done with this? Please let me know so that I will start a new topic that is known as kohlraush law. Are you writing it, Hamza? Okay, let me know when you are done with this. Very good. Write a topic that is kohlraush law. Kohlraush law of independent migration of ions. Kohlraush law of independent migration of ions. So see, this is Kohlraush law of independent migration of ions. Before the equation was Debye-Huckel rule was only for or is only for a strong electrolyte, not weak electrolyte. But this law is for a strong as well as weak electrolyte. Strong as well as weak electrolyte. Like, okay. So basically, what does this law says? I'm going to write it and then I will explain you. Write with me. This law states that the equivalent, this law states that the conductivity equivalent conductivity of any electrolyte at infinite dilution dilution lambda naught eq is the sum of equivalent ionic conductivities equivalent ionic conductivities equivalent ionic conductivities of the cation and anion given by the electrolytes at infinite dilution first you are going to write this, then I will explain each and everything. And let me know when you are done with this. Very good. Now see, what does this law says? This law says that you can easily see equivalent conductivity of any electrolyte that may be strong or weak at infinite dilution. That means this is the equivalent conductivity of any and not n. We are talking about EQ. Equivalent conductivity of any electrolyte. It can be a strong as well as it can be a strong or weak. Is the sum of equivalent ionic conductivities of cation and anion. That means if it is made up of cation and anion, it will be sum of this, sum of cation plus anion. If you don't get it, I'm going to take an example. If you have like this and equivalent conductivity of, if we are talking about NaCl, then this will be equal to, you know that if you are going to dissociate NaCl into two parts, it will be basically Na plus plus Cl minus. So it is individually EQ of Cl minus Na plus. First I'm going to take Na plus lambda EQ infinity and then Cl minus. So this is how this works. If we are talking about the equivalent conductivity of NaCl, that means it is the sum of NaCl is a salt, that is a strong electrolyte, you know that, and NaCl is converted into dissociated into its ions Na plus or Cl minus. That's why it says that It is sum of equivalent ionic conductivities of cation and anion given by the electrolytes at infinite dilution. This is it about equivalent conductivity. Are you getting my point? Hamza, Sneha. If you have an, so could you explain? Yes, yes. Why not? So basically, what I want to tell you is that just see that MgCl2. Just I'm taking an example of NaCl. NaCl can be written as Na plus Cl minus. Now see, this will have a infinite dilution. Equivalent conductivity of infinite dilution NaCl will be equal to infinite dilution of equivalent of infinite dilution of Na plus Cl minus. Individually, the equivalent conductivity at infinite dilution of cation and anions. Sum of this equivalent conductivity at infinite dilution will be equal to the equivalent conductivity of NaCl. Now got it or not? When we are going to dissociate it into two part, Na plus Cl minus. So the sum of these cation and anions equivalent conductivities at infinite dilution will be equal to the equivalent conductivity of NaCl at infinite dilution. Got it? So can you write this for in the same way? NaCl, you just for NaCl I wrote it. Can you write it for MgCl2, Al2SO4, Al2SO4 whole thrice, and the last one AXB1. Please write this. Let me know if you are not able to do this, but this is very easy. Sneha and Hamza, if you have any doubt, let me know. Just let me know.
So it will be lambda infinity
See, what happens here? If you are going to
g
talk
square.
about just match it, it will be equal to lambda infinity EQ
G square.
Mg plus 2
Plus 2,
plus
sorry.
lambda EQ of Cl minus. Yes or no?
Yes.
Very good. If you are going to solve this lambda in Al plus 3,
It
sorry,
will equal
Al2SO4
to, yeah,
whole thrice will be equal to lambda
Al
infinity
plus 3.
EQ Al plus 3. Very good. Sneha, what about you? Lambda
4 will
infinity
be,
EQ SO4 minus 2.
yes.
If you are going to talk about this AX minus B, AX and BY,
So I don't know that.
this is general formula.
Then it will be
Very good. This is general. You know what?
plus
First is
x
always, if you are
minus
going to listen to me carefully, very good. First is always cation, and you know that what will be charge here, whatever is the number here. So that's why it is plus 2, and Cl, and whatever is the number here, that is 1. That's why it that will be negative. Second is negative, and since we need to balance it, so just multiply it by 2. In the same way, if you are going for this, you can see Al, then what will be the positive charge? First will be always positive, plus 3. And what will be the negative charge on SO4? This number, minus 2. And if you want to balance it, you can easily balance it. See, how many Al is there? 2. How many SO4 is there? 3. So this is it. Okay. So if you are going to dissociate it, A, and what will be the positive charge? This Y. And if you want to balance, if you want to write the anion of B, this is B, and it will come into negative. And what is the charge? Minus X. If you want to balance it, then see how many A is there? X. So multiply it by X. How many B is there? Y. So it will be this. Got it? Yes or no? Done, everyone. Very good. Very good, both of you. Wait a minute. Hamza, now see, I'm going again on the previous point. I'm going to change the slide first. Now see, what we get, this is equivalent, will be equal to the equivalent of cation plus equivalent, infinite equivalent of anion. This I wrote. Okay. So here I'm going to say what is lambda C, that will be equal to equivalent conductance, equivalent conductance of cation at infinite dilution. And the next is lambda infinity is equivalent conductance of anion at infinite dilution. Okay, is this clear to everyone? And you also wrote that for AXBY, for AXBY, this is basically XA plus Y plus YB minus X, YB minus. If you are going to write equivalent conductivity, it will be lambda infinity EQ of A plus and lambda infinity EQ of B minus. Okay, everyone, please write. Are you done with this? Everyone done with this? Very good. Very good, both of you. Now see, write a point. We just did Korloff's law in terms of equivalent conductivity, but the questions will be also on molar conductivities. So we need to learn what is the relation between equivalent conductivity and molar conductivity, so that we will be able to solve questions on Korloff's law in terms of molar conductivity also. So write a topic, that is relation between equivalent conductivity and molar conductivity. So see, we already know that molar conductivity is equal to kappa into 1000 upon m, and equivalent conductivity is equal to kappa into 1000 upon n. So here we already know from class 11 that normality is equal to valency factor. Normality is equal to valency factor into molarity. Valency factor into molarity. Valency factor is basically charge. So from this we can write equivalent conductivity. After solving this in terms of this, we will get molar equivalent conductivity will be equal to molar conductivity upon valency factor. Please write this. And after this, we are going to do this in terms of molar conductivity also. Everyone done with this? Thank you, Sneha. Okay, take your time. Done. So again, I'm going to take that example. Hamza, you are also done with this. Okay. Now see, again, I am going to take that example. X by will be xa plus y plus yb minus x. And if you are going to write equivalent conductivity, it will be lambda infinity equivalent a plus y plus lambda infinity equivalent b minus b minus x. Now we are going to write in terms of molar conductivity also. In terms of molar conductivity. So if you are going to write in terms of molar conductivity, lambda naught EQ will be equal to whatever is the charge on A will be divided. Basically, this is valence factor. The charge is valence factor and it is lambda m infinity cation of cation plus whatever is the charge on this will be divided. This is valence factor lambda naught m and this is for anion. So here how we are going to introduce molar conductivity in equivalent conductivity. And here lambda naught m c will be equal to basically limiting molar conductivity, limiting molar conductance or conductance of cation, and lambda naught m is limiting molar conductance, limiting molar conductance of anion. Y is basically y is charge on cation and X is basically charge on anion. So I just introduced molar conductivity also. There is a difference between equivalent conductivity and molar conductivity. In equivalent conductivity, you don't need to balance. But in molar conductivity, we need to balance it. I will just explain. Please write. This is equivalent conductivity. In class 11th, have you studied about equivalent concept and mole concept? Let me know when you are done with this. Let me know when you are done with this. Very good. Now see, always remember that I'm again going to write ax by, and you know that what it will be: x plus x a raised to the power plus 1, y b raised to the power minus x. And if you are going to direct write the molar conductivity, it will be, listen to me very carefully, lambda infinity m of what? A plus y plus lambda infinity m of what? B minus x. If we are talking about molar conductivity, then we have to, there is mole concept and equivalent concept. In equivalent concept, you don't need to balance, but in molar conductivity, mole concept, you need to balance. That means there is x mole of a plus y, that's why I need to multiply it by x, and there is y mole of b, so we need to multiply it by y. So this will be the molar conductivity. But if you are going to write equivalent conductivity, you don't need to multiply it by x or y. Are you getting my point, both of you? Very good. So can you write lambda infinity molar conductivity, lambda infinity molar conductivity of MgCl2, lambda infinity of molar conductivity of Al2SO4 whole thrice? Can you write molar conductivity? Wait a minute. Sometimes it's just stop working. Can you write the value of this? Yes or no? Just answer me. Hamza and Sneha. Yes. Okay, please try both of you and let me know if you got any answer and if you have got any trouble. What about the first one? First one, you have to do it like this. MgCl2 dissociated into Mg plus 2 and 2Cl minus. Just balance it. Cl minus it will be, but for balancing, we need to multiply it by 2. So the answer will be lambda naught M Mg plus 2. And what is the stoichiometric coefficient? 1. You can multiply it by 1. You will get the same thing. Lambda infinity M of Cl minus. But here the moles of Cl minus is 2. So you have to multiply it by 2. Now Al2SO4 whole thrice. If you are going to dissociate it, you will get Al plus 3 and SO4 minus 2. And for balancing, you need to multiply it by 2, 3 and 2. Now lambda infinity M will have a value L plus 3 and there is 2 moles, so multiply it by 2. And again lambda infinity SO4 minus 2 M here. So we need to multiply it by 3 because there are 3 moles. Very good. So this will be your answer. Everyone done with this? Very good. Thank you, both of you. Let me. So if you are going to write the same thing for lambda EQ, you know what you will get. MgCl2. You will get lambda infinity EQ Mg plus 2, lambda infinity EQ Cl minus. Yes or no? This we will get. Tell me. Both of you, please. Done up to this? Very good. What about you, Hamza? You are not speaking. Okay, there is a question which is very easy on kohlraush law. Hamza, are you there?
Yes, sir.
Okay. Calculate lambda naught M for CaCl2 and MgSO4, also and MgSO4. From the data given from the data given below. What is the data? You can see lambda naught m for Ca plus 2 is given as 119 Siemens centimeter square per mole. Lambda naught m for Cl minus is given as, wait a minute, 76.3 Siemens centimeter square per mole. And also it is given that lambda naught m for Mg plus 2 will be equal to 266 Siemens centimeter square per mole. And it is also given that lambda naught m for SO4 minus 2 will be equal to, wait a minute, sorry, this is 106, this is 106, and this is 160 Siemens centimeter square. So we need to calculate. Can you do this or I should explain? Hamza and Sneha. We need to calculate lambda naught m for CaCl2 and lambda naught m for MgSO4. Can you do this or I should explain? Please let me know. Okay. Now see, I'm going to do the first, you will do the second. Lambda naught, wait a minute. Lambda naught, infinity or lambda naught you can write, m for CaCl2. First of all, you are going to dissociate this CaCl2 into ions. You know that there will be Ca plus 2 Cl minus. And we are talking about m, molarity, molar constant of conductivity. That means you need to balance because it's mole concept. And in mole concept, we need to balance. So you are going to, you just balance the equation now. Will be equal to lambda naught m for Ca plus 2 plus lambda naught m for Cl minus. And you know that there is 2 mole of Cl, so you will multiply it by 2. Now put the value is given 119 for Ca plus 2, 2 into, and for Cl minus it is given that 76.3. It will be this much Siemens centimeter square per mole. Now you can also see that 119 plus 2, 3 is 6, 2, 6 is 12, 2, 7 is 14, and then 15. And if you are going to add it, it will be 0.6, and then 2911, and then 5167. So it will be approximately 271.6. How much it will be? 271.6 Siemens centimeter square per mole. So this is how we are going to calculate molarity lambda m for CaCl2. Can you do the second part, MgSO4? If you got this, you can easily do that. Let me know when you are done with this. Okay. Please let me know the answer of MgSO4. Lambda not M for MgSO4. Are you done with this? The second one is more easier than the first. Very good. Hamza, are you done with this? Okay. So the answer will be basically 266. You can do it easily. By lambda not M, MgSO4, it will be lambda not MMg plus 2 plus lambda not M SO4 minus 2 will be equal to, it is directly given and it is balanced. If you are going to dissociate MgSO4, you will get 1 mole of Mg plus 2 and 1 mole of SO4 minus 2. So whether you are going to multiply it by 1, it will be the same. So the value is given as 106 plus 160. That will be equal to 266 Siemens centimeter square per mole. Okay. Hamza and Sneha. Very good, Sneha. You got the right answer. Now, the next question. The next question is basically lambda not M for NaCl, comma HCl and NaSe are 126.4, comma 425.9 and 91 Siemens centimeter square per mole, respectively. Calculate lambda naught for HAC. Let me know if you are unable to solve it. I will explain it. It's very easy. You'll get your answer. Sneha and Hamza, can you do it? Yes or no? Okay, try it. I'm waiting for your answers. That's very good, Sneha. You got the right answer. Hamza, let me know if you need any explanation for this question. Very good, Sneha. Hamza, are you there? Sneha, how did you solve it? So it is like this: lambda naught m for NaCl will be equal to lambda infinity Na plus lambda infinity m Cl minus, again lambda m infinity sorry, both of you, just you are disconnected. Now NaCl, after NaCl you can see it is HCl, so it will be equal to lambda naught m H plus lambda m naught Cl minus, and again NaC will be equal to lambda naught m Na plus lambda naught m Ac minus m Ac minus. Now we know what we need to calculate is lambda naught m for HAC. That means we need to calculate the value of lambda naught m for H plus lambda naught m for AC minus. So what we need to do is from these three equations, 1, 2, 3, we need to make this equation. So where is H plus? So in equation H plus, and where is AC minus? So in equation 3, this is 2, this is 3, and this is first. So we are going to make H plus AC minus. So in this case, you need to add 2 plus 3, equation 2 plus 3. And you can see with equation 2 and 3, we are getting Cl minus and Na plus, which is extra for us. So I am going to minus equation 1. So what we just did is lambda naught M NaCl plus lambda naught M HCl minus lambda naught M NaC. So here, you know what we are going to do is lambda naught M Na plus. Just see it and you will get it. Wait a minute. It just stop. Now you can see lambda naught M Cl minus O4. What I need to do is add second and third equation. So I am going to add second equation, that is H plus lambda naught M Cl minus, and then add the third equation lambda naught M Na plus, and then lambda naught M AC minus, and subtract the first equation, that is lambda naught M Na plus minus lambda naught M Cl minus. Now you can see this Na plus and Na plus will be cancelled. This Cl minus and Cl minus will be cancelled. So what we get at last is lambda naught M H plus lambda naught M AC minus, and it will be basically lambda naught M HAC. H plus AC, that will be HAC, and putting the value of this, that is for NaCl, it was wait, what I did mistake, what I mistaken here is that second equation we need to write second and first. Second plus third. What is the second equation? You can see the second equation is lambda naught M HCl plus third equation is lambda naught M NaCl, and minus first equation is like this. Now going to put the value and you will get your answer. So the HCl value for HCl will be 425.9 plus NaSC value of the third will be 91 minus 126.4, and you got your answer, that is 390.5 Siemens centimeter square per month. This is how you did it, Sneha. Very good, very good. So now I'm going to share another screen so that you will get some questions to attempt. So you are going to attempt question number 1. Please do this question number 1. Let me know the answer. Very good. Hamza, are you there?
Yes, sir.
Okay. What is your answer for one?
Right.
Please message me in chat box because your voice is cracking a lot. Okay, Sneha, question number 5 attempted. Is the answer D. NH4Cl. Yes, it will be. Very good, Sneha. Please do this question. We just did this. Please do this question. Yes, Sneha. Very good. Hamza, are you able to solve it or not? Please tell me. Very good, Sneha. Attempt question number 11, please. Hamza, can you chat me in? Can you message me in chat box? Which questions you haven't solved yet? Any questions? Did you solve the first question? Did you solve the first question, Hamza? You were silent all the time. Then how I will come to? I would know that you are not solving. At least you should speak up. Hmm. At least you should message me, na, Hamza. This is very bad. You are only sitting there and watching the screen. Okay, so I'm sharing another screen. This screen. Hamza, are you able to understand this question? Please, whenever you don't understand, please tell me. Can you solve this question? What you need to do is to find the value of molar conductivity of HAC. So you just need to dissociate this. I just dissociated it, and HAC, H plus AC minus. Just search H plus AC minus. This and this is here. So you need to add 2 plus 3. And with H plus AC minus, you will get Cl minus and Na plus, which is extra. We don't need it. So what you need to do is minus equation 1. So what I did here is 2 plus 3 minus 1. And when you do it, you will get only H plus and AC minus left here, which means HAC. And put the value according to the equation. Like HCl has a value this much in the question given. NaSC has this value and NaCl has this value. Just solve it and you will get your answer. Please reply me in chat box. Did you write it or not?
Yes, sir.
Okay. So can I move to the next question?
Yes, sir.
Please solve this question number 11, Hamza. Question number 11. Sneha, you are going to do the question number 13. I'm waiting.
So the answer is
What you just said? Question number 11. Question number 11, answer B. Can you tell me the answer, Sneha? Question number 11. Very good. It's right answer, Hamza. Now attempt question number 13. 139.5. Wait a minute. I'll just let you know. Ba plus 2 and Cl minus. So it will be 127 plus 2 into 76. Ionic conductances. Please attempt question number 13. I'll just cross check it. I'll just cross. So basically, see here that there is equivalent conductances. This is equivalent conductances. And when we talk about equivalent conductances, you just need to add 127 plus 76. You don't need to wait a minute. Yes, just add it. 127 plus 76. It 127 plus 76. 203 is the answer. Sneha. So this question number 13 is for your homework. Please take a screenshot of this and this, and also for this, and also for this. These 4 questions are from homework. Please take a screenshot and let me know. Okay, thank you. So this is it for today. In the next class, that means most probably tomorrow, I'm going to take a test for all of you. Okay, Sneha and Hamza.